Continuation. Let's start with the chapter thermodynamics, right? So thermo means heat, dynamics means what is heat is not moving. Actually, heat is getting transferred. So that part we learned in heat transfer. But here, actually, these two the temperature, pressure, volume, pressure. In chemistry, you have learned all those things. Just the little diversification is there in the physics part. That part will go for in details. You have learned very well in chemistry also. Okay. But some of the part which will be required because in sometimes the kinetic energy will be converted to heat energy. Yes or no? Let me bullet is fired. It is going with very high velocity and how the kinetic is getting converted into heat energy. So there is a link. So we'll see those part of the in this physics chapters, right? So it's a chapter, it's a branch of science that deals with the concept of heat, right? Temperature, how heat and temperature getting converted, right? Interconversion of heat and other forms of energy. So there are some words that we're going to learn in this chapter, like thermodynamic system. Should thermodynamic system means what? मतलब, it's a assembly of large number of particles having certain value of pressure, volume, temperature, right? We're considering a system. It is under certain pressure, having some volume, having some temperature. So those total things is known as thermodynamic system. Surroundings, everything outside the system which can have a direct effect on the system is called surroundings. Let you have taken the gases in a container, right? And it is having some temperature, but surrounding temperature is somehow greater than this or somehow lesser than this. So it is going to affect the temperature inside the gas container. Yes or no? So that is known as surroundings. And what are thermodynamics variables? Thermodynamics variables, most probably, those are like pressure, volume, and temperature, right? These things you have learned already. So how the pressure, temperature, and volume, pressure, volume, and temperature all are related means they help us to study the behavior of a thermodynamic system. If pressure is changing, velocity and temperature, how they vary. If volume is remaining constant, how pressure and temperature changes. There are some laws which also already learned in your chemistry also, right? Then equation of state. Equation of state means students see here. Equation of state means what? The mathematical relation between the pressure, volume, and temperature of a thermodynamic system is called equation of state, right? For example, you're very much acquainted with a relation n moles of ideal gas, right? N moles of ideal gas, you know a relation. What is that? N moles of ideal gas. What is that, student? That is PV is equal to nRT. You are acquainted with this relation, na? Real gas constant, right? In chemistry, you had learned this. We'll see those part also, right? And there is also two terms you'll be getting while learning your while going through the line by line reading of NCERT book. You'll be also getting these two words like adiabatic wall. Adiabatic wall क्या है? Student, an insulating wall. Adiabatic wall means an insulating wall. An insulating one means it can be movable. That doesn't allow flow of energy. Insulating one means that does not allow, right? That does not allow flow of energy or heat from one to another. From one to another, right? Yes or no? And there is also diathermic wall. Sometimes some books it is written diathermic wall. Just to get science means in you have to get acquainted with, because after this, if you're taking mechanical engineering or any of the branches, then you will again coming across those words of 11th and 12th, and the little more higher versions will learn. But these wall again will come into being. Diathermic wall. Diathermic wall is a conducting wall that allows energy flow, right? This is the diathermic wall means a conducting wall. Conducting wall that allows energy flow. That allows energy flow, right? Okay. Again, student, let's go to this is thermodynamics. Different zero. What is zeroth law of thermodynamics, right? And what is meant by thermal equilibrium? What is heat? What is internal energy? And what is work? How they are related, right? So let's go first to zeroth law of thermodynamics, right, student? Zeroth law of thermodynamics. Zeroth law of thermodynamics. Give heading. Zeroth law of thermodynamics. What zeroth law of thermodynamics says, right? Right. If a body A, right? If a body A, if a body, see here, if a body, zeroth law of thermodynamics क्या है? So if a body A is separately in thermal equilibrium with B, means A is thermal equilibrium with B and A is thermal equilibrium with C. Then we can see B and C are also in thermal equilibrium, right? Means A and B are having same temperature. Means here see thermal equilibrium means what? They are said to have equal temperature. If A and B are same temperature and A and C are same temperature, then we can see na say na B and C are also same temperature. So that is known as zeroth law of thermodynamics. Zeroth law of thermodynamics, right? Then after this, let's know about what is heat, what is internal energy, and what is work, right? Give heading heat, so that we can relate them in first law of thermodynamics, right? Students, see here. Heat is what, student? What is heat? Heat is defined as the transfer of energy, right, student? Heat is defined as the transfer of energy. It is defined as the transfer of energy across the boundary of a system. Across the boundary of a system due to a temperature difference. Due to a temperature difference between the system and the surroundings. Between the system and its surroundings. And its surroundings, right? It is a microscopic color physical quantity. Students, you know SI unit. What is SI unit of heat? Anyone? Joule, right? And practical unit is also calorie, right? And 1 calorie, how much joule, students? Already we have learned 1 calorie is equal to 4.2 joule. Yes or no? Got about heat?
Yes.
Let's let know about, we're getting acquainted with the different terms of this chapter. Internal energy. Next is internal energy. Right. What is meant by internal energy, students? See here. Student, internal energy is the sum of molecular kinetic and potential energy in a frame of reference relative to which the center of mass of the system is addressed. That means, as I told, let a bullet is moving, right? After some time, heat is getting, when a bullet moves, friction is created in the surround air also, right? And due to kinetic energy, sometimes it's also getting converted into heat energy. Yes or no? So molecular kinetic energy, when gas is at room temperature, if you're increasing the temperature of the room, then definitely the bond between the molecules of the gases and atoms, they will break or not, and the separation will increase. The kinetic energy between them will also increase. Yes or no? So right, students, internal energy, internal energy is the sum of molecular kinetic and potential energies potential energies in the frame of reference relative to which relative to which the center of mass, relative to which the center of mass of the system is at rest. The system is at rest, right? It includes only energy associated with the random motion of the molecules, right? जो एनर्जी है मैकेनिक्स को कंसीडर नहीं किया जा रहा है, रैंडम मोशन of molecules of the system, right? That means total energy, internal energy U is equal to kinetic energy plus potential energy. Student, one thing just keep in mind, internal energy is thermodynamic state variable. Means state variable means the internal energy of a given mass of gas depends on the state described, like pressure, volume and temperature. It does not depend how this state of the gas have achieved, what is the path followed, but presently what is the pressure, what is the volume, what is the temperature. That is going to decide what is its internal energy. So got an idea about heat and internal energy? Then we'll go to work, right? How to find work done when the system, when work is done on the system, when work is done by the system. Then we'll go to the indicator diagram, right? It is very important part here. Then we'll go to first law of thermodynamics. And student, change in internal energy in a cyclic process. Let a gas is moving. Initially the gas was having some pressure, volume, temperature, and it moved to some certain of temperature, pressure and volume. Then it came back. In this case, student, no molecular attraction is there, right? Internal energy of the ideal gas is totally kinetic, and it directly depends on temperature. That means in sometimes there is no potential energy. It is, internal energy is kinetic energy, and that is also directly proportional to temperature, right? And let's know next work done. Give any work done, right? Work done, that is W. What is work done, students? See, student, when system go from initial states, let initially a system is having, a gas is having pressure P1 and volume V1, right? And it moved to a final state. Let this is the initial state of the gas. Initial state system, initial state pressure and volume P1 V1, and final state pressure is how much? P2 and V2. Getting student? The work done by the system and the surroundings is obtained by P is equal, work done is equal to P dV V1 to V2. You can also prove this one. How pressure multiplied with volume will be work. Let's see. Student, can you prove it? Pressure multiplied with volume. What is pressure, student? Pressure is equal to force by area, na? Right? And I'm multiplying force by area into volume. So let's see, force by area, volume means area into some length. Yes or no? So L cancel. So that is force into displacement is work or not? Understanding now, students? So dimensionally also you can prove that P into dV. Let pressure is there, let the volume is changing. From what value to what value the volume is changing. From there only we can find the work done or not. Students, getting my point? Students, are you getting this point?
Yes, sir.
So next, let's see. We can see here. So let initially we'll come to indicator diagram, right? Let this is pressure, this is volume, right? Let this is the initial case, this is the final case. So here see, initially pressure was P1, in initial pressure, and this was also initial volume. Let this is the final. This point we're saying is final point, and this point we're saying is final volume. Okay, student, understood? So work done, the students see here, internal energy, heat and work depends on the path followed to reach the final state. But the work done by the gas in expansion, students see here, volume is decreasing. That means expanding or contracting. Here initial volume was at this point, final volume. Let volume is increasing. That means expansion is taking place now. Yes or no?
Yes, sir.
So work done by
Yes, sir.
expansion from initial state to final state. That is what? How to find, whatever. If you want to find work, then we have to multiply this area. Na? We have to multiply pressure into volume. So directly from any indicator diagram, area under area under the curve connecting the states of pressure and volume. We can find the work done or not, students? Area under this curve will give us what? Work done. Because pressure into volume. Yes or no? Understanding all, na? Students?
Yes, sir.
So next let's go to indicator diagram. What is meant by indicator diagram? Then we'll go to what is first law of thermodynamics. So before to that, let's go to indicator diagram. Today we'll learn in the first lecture only we'll learn about indicator diagram. Then we'll go to first law of thermodynamics. Right. Next class we'll study about first law of thermodynamics. So let's know about indicator diagram. Give hearing students indicator diagram. One question we are going to get on this indicator diagram. Right. So let's know that. Students, indicator diagram means what? Graphical representation of systems with the help of two thermodynamical variables. That is called indicator diagram. Yes, sir. So indicator diagram का definition लिखो. A graphical representation, right? A graphical representation of the state of system with the help of two thermodynamical variables. With the help of two thermodynamical variables is called as indicator diagram. It's called as an indicator diagram. Understood, students? Indicator diagram, right? I'm giving you some examples, students. See here. Means when compression takes place, when expansion takes place. In which graph the expansion is going and in which graph the compression is going on. Let's take the graph, right? Let's. This one is student pressure axis. This one is volume axis, correct? Same. In this graph, this arrow mark is like this. Means this is the initial case. This is P1, right? And at that particular case, it is V1. Getting the students? A point, this one. This is pressure is P1, volume is V1. And after some time, this is the volume V2 and this is the pressure P2. This is point B. This is P2 and B2, V2. So what do you think? Volume is increasing. And what is here? Expansion or compression, this one? Semi. Volume is increasing means expanding. Yes or no? Right. This is expansion. What happens in compression, students? If I'm compressing a gas molecules, then the volume will decrease, na? Yes or no? So that means the same graph we can draw like this. Understanding now? Let this is B point, this is A point, arrow is like this, correct? So what is the point here? This is P2 and the volume is let V2. This is V1 initial case and the pressure is P1. So this is A point, this is B point. So this is what? This is compression. Volume is decreasing. Understanding, students? So what is the importance of PV diagram, students? The area under PV diagram is numerically equal to the work done by a system. Yes or no? Are you getting, students, my point? So area under, right? Area under the PV diagram. Area under PV diagram is numerically equal to the work done by a system or on the system, right? Understood, students? Getting or not? And the formula that I told, we can also derive this one. Just wait, just 1 minute, we can derive that one also. right? Just see here. Then next class we'll do this numericals on this, right? Let here, let in a container we have taken. This is a container, right? Enclosed container. Let this is the piston, right? Correct, na? That initially it was at this condition. The dotted line initially at this condition, right? Initially it was at the dotted condition. That means this change, the change from this to this is let dx, right? And let this some pressure is exerted pa. And friend, you know force is equal to pressure into area, है कि नहीं? And small work done is equal to f dot dx, ना students? And f की जगह में pa dx लिख सकते हैं कि नहीं? Can you write or not? And area into dx, that is p into dv. Are you getting this one, students? Yes or no?
Yes.
Area into small displacement dx. So work done, w is equal to how much? Work done dw. So that is equal to how the volume is changing, p dv from v1 to v2. Understood ना students?
Yes, sir.
ठीक है. और इस पे एक चीज है स्टूडेंट जो हमें जानना चाहिए, जो है एक नॉन साइक्लिक प्रोसेस और एक साइक्लिक प्रोसेस. वर्क डन ड्यूरिंग ए साइक्लिक प्रोसेस, work done during a non-cyclic process. So non-cycling process is the one which system does not return to the initial state. It was at some state, it is going to other state. That is known as initial state. So here, cyclic process and non-cyclic process. ठीक है, cyclic. चलो पहले non-cyclic करते हैं, right? Non-cyclic process and cyclic process. तो नॉन साइक्लिक प्रोसेस पे क्या होता है? सिस्टम क्या होता है मैंने बताया, system does not return to the initial state. Let it is going from this point to this point, right? It is not returning. This is a point, this is b point. This point is pressure p1 v1, right? This is pressure and this is volume, and this point b point, that is pressure p2 v2. So here the system does not return, right? System does not return to the initial state, right? System does not return to initial state, right? So here what we have to do, the area under this will give us what? Area under this total graph will give us what, students? Work done, right or not? है कि नहीं students? और cyclic process क्या होता है student? What is meant by cyclic process? See here, this is non-cyclic process. Then let's go to cyclic process. Cyclic process means student a process in which the system returns to its initial state after undergoing a series of changes. Yes or no? Here what happens? System returns, right? System returns to initial state. अगर graphically दिखाएं हम, system returns to initial state, right? Let's see here. So this is pressure and this is volume, right? This was the point A. System gold from in the path A to B, it went from X, and again it returned from to A in the path Y, right, students? Here you can find the area also or not? Getting the students? AXB. It is going in this path and returning from BYA. Getting or not, student?
Yes, sir.
Yes, sir.
So what is happening here? Work done during the cycling process. कैसे निकाले? How to find that one? Student, work done by the gas during the expansion. That is area under AX BCDA. इस point का नाम C दे देते हैं, इस point का नाम DA दे देते हैं. तो first, it is going from AX BCDA. पूरा इसका एरिया जब निकालेंगे तो स्टूडेंट हमें वर्क डन मिल जाएगा एक्सपेंशन की टाइम पे, राइट? गेटिंग और नॉट?
Yes, sir.
और फिर हमें W2 मतलब वर्क डन ड्यूरिंग कंप्रेशन कौन सा वाला होगा ना? BYADC. यस सर, नो? BYADC again B. Students getting na? This path. Getting or not? So that is negative area W2. Correct or not? And net work done कैसे निकालेंगे स्टूडेंट? नेट वर्क डन क्या करेंगे? Net work done is W1, area is more na? So net work done W is equal to W1 minus W2. Correct? है कि नहीं?
Yes, sir.
That is only that area only will be how much? Na, a plus area, that is plus area under A, X, B, YA. Understood, student? This part only.
Yes, sir.
Getting or not? So for a cyclic process, we have to find the area, this area, AX, BY. Will during expansion, how much work done? During compression, how much work done? This is negative means this is compression, right? Yes or no, students? Understood? So we'll do numericals on this on the next class. Okay. So this must not you update. Just go through your NCERT book and learn it line by line. The next class we'll do numericals on this, right?